We're going to be talking about the algebra of functions, which means we're going to take algebra functions and then we will add and subtract, multiply, and divide them. So it just gets a little bit more involved. The very first thing we have here is notation. Okay, so if you look at this section, your homework may give you something like f plus g of x, but it's typically easier to think of that in terms of its other notation, f of x plus g of x. And so we have, if they put a minus in between f minus g, then it's f of x minus g of x. Written together, we're simply going to multiply. And so they're all correct ways to write it. Now, of course, when we divide, whatever you're dividing by is not equal to 0, which was this says provided g of x doesn't equal 0. Now, it is important, and this is highlighted, that for us to be able to do this, x has to be in the domain of each function. So if it's undefined for one of the two functions, then it's undefined when we put them together. Okay, it has to be in both of them. So this is, again, this is the same as f of x plus g of x, which means I have x plus 1 plus x plus 3 squared. Now, it very well it's likely we need to simplify this so far as possible. So x plus 1 is just x plus 1. X plus 3 squared, you can FOIL it out, x plus 3 times x plus 3, and that comes to x squared plus 6x plus 9. So here I've just combined like terms. So f plus g of x is x squared plus 7x plus 10. Now f plus g of 6, you kind of have some options here. I can actually take that and plug that into what I just got as the answer. So I know that this is f plus g of x, and now I need to plug a 6 into f plus g. I can simply take the 6 and plug it into the answer I just got. Okay, simplify that. So we get 36 plus 42 plus 10, so that is 78/98. Or, just because it's an option, I could have said, well, that is f of 6 plus g of 6, and you would definitely need to do it this way if I hadn't already simplified and found what f plus g of x was. Now f of x would be then 6 plus 1, and g of 6 would be 6 plus 3 squared. 6 plus 1 is 7. 6 plus 3 is 9. 9 squared is 81. So did I add wrong up there? Because this is going to come out the same both ways. That I did. 78/88, obviously 88, not 98. Some of you may have noticed I struggle with this online writing. So we get 88 both ways. So I actually prefer to do the second one because even though I already know what f plus g of x is, the numbers just seem smaller and easier to work with, as well illustrated by the fact that I misadded up there. So I can do either one of those. It doesn't matter. You should get the right answer either way. You can do both if you want to make sure you're getting the right answer. That's a great way to do it. So here, f of -4 plus g of -4. It's an option. You can do them separately like I did, or you can do it in your found function. So f of -4, I take -4 and I plug it into this f function, so I have -4 plus 1. And then for g of -4, I have to plug -4 into the g function, so I have -4 plus 3 squared. Now -4 plus 1 is -3. -4 plus 3 is -1, but -1 squared is a +1. So the answer there is -2. Now I can just let's just verbally check it over here. That would be 16 if I plugged it in on that left-hand part. -4 times 7 would be -28. So 16 and a -28 would be -12, plus 10 would be -2. So it's the same answer either way. Now, it doesn't happen as often, but if we needed to add functions graphically, okay? Graphically, you take the y values. Now let me just kind of back up again. F plus g of x is equal to f of x plus g of x. But f of x is a y value, and g of x is a y value. So if we add the two y values, then we get a new y value, which represents this f plus g of x. And that's what we're looking at here. So I know that this is blurry, but this graph I just couldn't replicate, so I just kind of had to pick it up out of the textbook. But what you can see is that if you take a particular function, this pink one or red one is g, and then this turquoise or blue is f. If we add the functions f plus g, the way we do that is we add their heights. So starting off, this first height was 2 at 0, so g of 0 is 2. F of 0 is 7, so when we take this 2 plus that 7, that's why this black one's at 9. You can do this with any particular point, so if you take the x value of 4, g of 4 is 4. F of 4 is 7. So now if we take the 4 plus the 7, we get 11. And we see that f plus g of 4 is 11. Okay? If we needed to add these functions graphically, x plus 1, we're just going to kind of do a little sketch. This is certainly not going to have precision because of this being online. But if we had some sort of a sketch, what happens is that if I can draw, and let's just let that be the axis, curvy as it is, x plus 1 then is a line that goes through the y value of 1 and has a slope of 1. So we're just going to say it kind of looks like that for x plus 1. What happens with the square root of x plus 3 is that it starts at -3. And then it ends up kind of doing that. So if we, without real values then, if we wanted to add these, what would happen is that you cannot add any part of it that does not define for both of them. So I'm going to erase part of this line there, and we're only going to use the part that starts here. See, I'm not allowed to go further down than that. And what happens is you take this negative height, which let's just say that is at -3. That would be at -2. Negative 2 plus 0 is negative 2. Now some of you might think, where did she get negative 2? Well, the red line, if I'm using x as negative 3, it might make more sense, particularly since we're online, if you just think of values. When I plug in a negative 3 here, I got a negative 2 here. On the other hand, if you plug in a negative 3 up to that second graph, x, y, you plug in a negative 3 plus 3 is 0, and the square root of 0 is 0. So if I add those two y values, negative 2 plus 0, I get negative 2. All right, let's try at the negative 1. If I plug in a negative 1 to that first function, negative 1 plus 1 is 0. That's where it's crossing right here. If I plug in a negative 1 to the second function, negative 1 plus 3 is 2. The square root of 2 is approximately 1.4. So 0 plus 1.4 is going to be 1.4. So at negative 1, it had to go to 1.4. Now let's just try one more number so you can just see the adding, even though it's so hard online. If I plug in a 0, 0 plus 1 is 1. If I plug in a 0 on the other one, 0 plus 3 is 3, but the square root of 3 is approximately 1.7. So if I add 1 plus 1.7, I've got to be at 2.7. So 2.7 is going to be quite a bit further up. So what we can see then is that if you take the line, the first line, and then you take the second one, it doesn't end up being either one of those, but it does end up taking their y values and adding them. So on this one on the left, that was nicely done. That's why I had to copy and paste it for you. This graph f plus g is not like either one of the first two graphs, but it does take the y values and add them. So this is what that other graph should have looked like if I could have done it beautifully. So we can go back and laugh at my attempt, but what happens is that x plus 1 is a line. And so that yellow, where they have x plus 1, I was trying to do that line here in red. Okay? I did have it crossed at the right place. Then the square root of x plus 3 is that curve, and it starts over at negative 3. They have it in gray. So mine was in blue. It went to negative 3, and it arced over. But when you try to combine those two, which is a really ugly equation if you look at the way it's typed out, what happens is that it takes those heights and it combines them. It's not like either one of the first two, but it is important to note that it starts only where both graphs start. That's why when I was doing that, I erased part of that line because I only wanted this green one to start where the two started. So that's the same problem, but this was what it would look like if I could do this for you online and make all of the lines smooth. Okay? Now, using the graph right, determine the domain of each of the following. So domain is about the x values that are used. So let's look at this. If we take, and I'll erase this in a minute, but if we took this f function, which is this blue one, and we put it to the x-axis, what happens is that it ends up just like squishing it to the x-axis. That blue one covers everything from 3 to 14, and it does include the 3 and the 14. So when I want to write the domain for that one, it's going to be closed from 3 to 14. All right, so let's erase that line and let's do another domain. G of x. G of x is the one in green here. So if I'm ready to do the one in green, if I take that one down to the x-axis, this point comes down to here, and then it uses, the green one then uses everything from 2 to 13. It does use both of those, so 2 to 13. And it's closed. All right, so what happens when we try to add these together? Well, I've mentioned and somewhat illustrated on the other slide, you can't combine them unless they're both occurring there. So if you look at where these both occur, you're going to go from here to here, and that's where their overlap happens. So when we add these, it has to go in that area. So when I add those, it's going to be from 3 to 13, and it can include them. So notice that's not like either one of those, because it started where the f function started, but it had to stop where g stopped, because it can only work where they both work. All right, what if we're going to divide? Well, the extra stipulation on the division is that what you are dividing by cannot equal 0. So if I look up here, I'm dividing by g of x. So first of all, it has to work for both of them. So we're only looking actually in that area from here to here, like I just erased. But I'm not going to be able to use all of it. I guess I'll put that back. We're looking at this area. However, I cannot use anything where in that range there, or in that domain, where g of x would equal 0. But g of x does not equal 0 anywhere in that range. It's above the x-axis everywhere. So I can, again, use all of those values, and I can have 3 to 13. On this next one, though, I'm dividing by f of x. Since I'm using both functions, I'm still narrowed to looking at this 3 to 13, but I cannot use any place that f of x equals 0. But f of x equals 0 right here. So I actually cannot use the value of 5. So I'm going to have to get rid of that one. So I can go from 3 to 5, but I can't use 5. Remember, I'm going to jump over it. And then I can go from 5 to 13, and I can use it. So it had to be in the domain of both, but if you're dividing by something, whatever value you're dividing by cannot equal 0. Now, you are going to have problems like this where it almost just seems like the homework is on sale. They will give you a simple little function or functions, and then they are going to ask you about 8 or 9 parts, okay? So you have to find the domain of 1, 2, 3, 4 functions, and then find the combinations of 1, 2, 3, 4, 5 functions. So if part A has 4 answers, and then there are 5 more answers, there are 9 parts to this problem, okay? Now my recommendation is that you just do them all at once and then type them in all at once. It seems to go faster like that rather than do them one at a time. So I like to kind of combine things along the way. First of all, for domain, the domain of this top one is negative infinity to infinity. Because it does not have any square roots, it doesn't have any fractions. This one is negative infinity to infinity. Again, no even roots, no fractions, so there's no problem. So if I'm going to do part A, f plus g, f minus g, f times g, and f divided by g. Okay, well, these first three, since I am adding, subtracting, and multiplying, I don't have to do the extra limitation. I just have to make sure it works for both of them. And all the numbers work for both of them. So for all three of these, the domain is negative infinity to infinity. Because if there is no fraction and no even root, then there is no problem. On this last one, however, I do have a fraction because I have g of x in the denominator, and I'm not allowed to let g of x equal 0. So since I know g of x cannot equal 0, then that means when I go back up there, that means x plus 2 cannot equal 0, which means x cannot equal negative 2. So the domain is going to run from, it could be just like the other ones, except for that I have to skip over negative 2. So for this last one then, the domain goes from negative infinity to negative 2 and is unioned with negative 2 to infinity. All right, now I'm going to kind of just switch up colors to have our lines stay straight, and we'll do our other ones. When we add these functions, this means I need to add x squared minus 4 plus x plus 2. So that's going to be x squared plus x, I'm looking at like terms, minus 2, because of my like terms, negative 4 plus 2. All right. F minus g of x, which means I have x squared minus 4 minus x plus 2. This one, though, the x squared minus 4 stays like it is, but I need to distribute the negative, so that becomes negative x, or minus x, minus 2 more. Combine those like terms, x squared minus x minus 6. F g of x means f of x times g of x. So I have x squared minus 4. And then I'm just going to FOIL that with x plus 2. So I have first, outside, inside, last. F over g of x, I have, oh, should have put an x here, x squared minus 4 over x plus 2. That is a minus there. I'm going to want to factor, so the top one is x plus 2, x minus 2 over x plus 2. Those cancel, and this simplifies to x minus 2. That's why that domain is so important, because this original fractional rational expression looks just like x minus 2, except for there's a hole in it where that canceled, and that's why it says x cannot equal negative 2. That's all related to the same thing. Now I realize I'm out of room going down, so we're going to put f over here in this white space. So for f, it says g of x, which means g of x times g of x. That's x plus 2 times itself. So FOIL, first, outside, inside, last, but these, since they're identical, they fit a pattern. It's the first one squared, multiply and double it. That's because if you did the outside, you get 2x, the inside's another 2x, and then the last thing squared. So this is just kind of a tedious work. So I'd say do the domain first. It's everything that's in both of them. So if there's something you have to throw out, you have to throw out of all of them. And then additionally, you have to throw out anything that makes a denominator 0 if we have a denominator for like that f over g. All right, so shifting gears a little bit. Previously, we've talked about the slope of lines. And even though it's not technically slope, you can use that idea with curves too. And we really know that curves do not have a steady rate of change. But if you take two particular points on them and you say, okay, maybe I'll do this in yellow. If we go from this point and then we wanted to go to this point, we could connect those, and I wish I could do that in a straight line. It's not too terrible. And that yellow part would have a slope. And so what that does is it gives us an average rate of change. So even though this might illustrate something that starts off very, very slow, and then it speeds up extremely rapidly, and then it levels off. And maybe if this is speed, you know, I'm stuck at a light, this surely is not me. But then I start speeding up, and then I pull out to pass somebody and speed up just really quick. Then I get back in my lane and level off my speed. Okay? What happens then is, you know, word problems like we had even in the previous lesson, we just talked about somebody traveling 35 miles an hour or 45 miles an hour. That seems so unrealistic. But if you ever look or calculate what your average rate of speed is, it is kind of in that area. My daughter does a logistics planning for a trucking company, and they calculate truckers traveling at the average rate of speed of 50 miles per hour whenever they're trying to track them. When I come to work or go home in the evenings, I rarely get up that high. It's in the 30s or 40s because of stoplights and different things. But you can use slope, and it finds the average rate of speed. So now, what was slope? Let's just remind you then. It was y2 minus y1 over x2 minus x1. And that same formula is going to let you find the average rate of speed, or the average rate of change. Okay. Now, this actually falls into being something kind of like this whenever we label things differently. So this looks like an impossible sort of a formula, but I'm going to go back and I'm going to erase our formula that we have, and let's just write things a little bit differently. Suppose that I said, well, there is some point on here, maybe where I have that very first value, and that is an x value. Now, I have another value over here, and it is another x value, but it's not the same because it definitely has this distance in between them, and this distance is h. So I started at x, and then I went a distance of h, which landed me at x plus h. Now, if this is my function, f of x, then the height of this very first x value I plugged in over here is f of x. And the height of the second one that I plugged in over here would be f of x plus h. Because if I had to plug in x plus h, I'm going to get f of x plus h. So my two particular points could be written as an ordered pair. This one is x, f of x. But this point is x plus h, f of x plus h, which just means the y value of that x, right? So now if we want to apply the slope formula, what happens is that it's y2. Well, what was my second y value? F of x plus h. Minus y1. What was my first y value? F of x. Over x2. Well, my second x was x plus h. Minus my first x value, which was x, which means combining like terms, those cancel, and I'm just left with an h on the bottom. So this says f of x plus h minus f of x over h. All right, so let's clean up the way that looks a little bit. I'll just say, okay, rather than write all that, why don't we just write h? Because x plus h minus x is h. That is the slope formula. It just looks very different. And now when you see this one, it's exactly the same. That average rate of change and the difference quotient and the slope formula really all work the same way. You are going to have some problems that ask you to find the difference quotient. So if you notice, you're going to need f of x, but you also need f of x plus h. I recommend you go ahead and find that first before you try to apply the formula. So if this is f of x, f of x plus h just means I need to replace all of the x's with x plus h. So this becomes 2 x plus h, and then minus 3. But I can simplify this to 2x plus 2h minus 3. Okay, so now I know what f of x plus h is. So now let's find the difference quotient. So you want to write f of x plus h. I've just found that, so I'm just copying it over. Minus f of x. Now since there's more than one term here, I've got to use parentheses so I can distribute that negative. And it's all over h. So now I've applied the difference quotient. The rest of the stuff I'm doing is what we kind of call algebra cleanup. Just kind of getting it entirely simplified. So first of all, if I distribute this negative, it's going to make that be a negative 2x and a positive 3. So now, looking at my like terms, 2x and a negative 2x cancel. A positive 3 and a negative 3, even though I said it backwards, are going to cancel. And this simplifies then to 2h over h, which is 2. And that's the answer. We probably need to do another one of those. Find the difference quotient. So if we're going to find the difference quotient, the first thing you want to do is just go ahead and let's find out what f of x plus h is, because we're going to need that. F of x plus h just means replace the x with x plus h. So since it was 1 over x, it is 1 over x plus h. So now I'm going to apply it. F of x plus h, 1 over x plus h, minus f of x, well, f of x was 1 over x, all divided by h. So that is just apply the formula, and again, now I need to do some cleanup. Now, how you clean this up, there are different approaches that you can take with how to apply to complex fractions. I'm just going to try to do one that I think you will understand. I'm going to take this h and write it over 1. So now I have the numerator divided by the denominator, but the denominator is a fraction. So I can apply that concept you've probably heard before of keep, change, flip. I'm going to keep the numerator. I'm going to change it to multiplication, and I'm going to flip the denominator over. Okay, so to divide by a fraction, it really means you can multiply by the reciprocal. Okay, so in order to go further with this stuff, I really need to work on getting common denominators and what have you. Okay, I've got to see what I can simplify here. So just, I can distribute first if I want to. Let me go ahead and distribute. I'm going to do that going down. 1 over h times this would be 1 over h times x plus h. And I could have distributed that on the bottom, but that's not going to help me get a common denominator. And then 1 over x times h, 1 over h will be 1 over hx. So I've sent that into both of them. So now, I have two fractions, but they don't have common denominators. I need to create common denominators. They do both have an h, but this one has an x plus h, and the second one does not. So I'm going to put an x plus h on the top and the bottom. So that now this one has what it didn't have from the first one. Similarly, I'm going to put an x on the top and the bottom of the first one. So now if you look, these have common denominators. All right, once fractions have common denominators, you can just go straight across the top. So just to kind of save me some room, I've got to bring this up a little bit. So what does this equal? Well, this first numerator is an x. Going across the top, I have minus x plus h. And it's all over h, x, and x plus h. Now on the top, again, because I have that negative, I need to distribute it. So when I distribute that negative, it's going to make that be a negative x and a negative h. But x plus a negative x will cancel out. So that is going to leave me on the numerator. I have negative h, and it's over h, x, x plus h. But this h on the denominator cancels with that h. Don't forget that there's a understood 1 in front of that h. So the h's cancel, and we get negative 1 over x, x plus h. And that's the answer. You have to be really careful in the algebra. I don't think applying the difference quotient is where most people make a mistake. It is on working out all the cleanup to get it simplified. If you get stuck on that and you don't know where you're making a mistake, please explain what you're getting, or even if you can, send me a screenshot, snapshot, something of your work so that you can show me what's going on there. Okay. So we have one last one to practice, just so you can see this. It's not a new concept, but again, very first thing I'm going to do, and this will be our last example just to help you get this idea, is I need to get f of x plus h. This part starts off easy enough. I'm just replacing the x with x plus h. I want to go ahead and simplify that, because anything I can do before I get it in that ugly fraction helps. X plus h squared is x squared plus 2xh plus h squared. So I'm just going to kind of line that out and put that. And now let's distribute again. So we get 2x squared plus 4xh plus 2h squared minus x minus h, now I've distributed that negative, minus 3. And that is f of x plus h. Okay, so now, for my difference quotient, I have 2x squared plus 4xh plus 2h squared minus x minus h minus 3 minus f of x. And now guys, if I minus f of x, what it's going to do is it's going to change all of those signs. So to save myself some room, I'm going to go ahead and do that. So that's going to be minus 2x squared plus x plus 3. Okay, so I know it looks like I've got the signs wrong, but that's because it was a minus f of x, so I distributed that negative. Now this is all over h. But now let's go see what can we cancel out. And this does actually happen. You should expect a lot of things to cancel. So 2x squared, and this minus 2x squared goes away. The negative 3 and this plus 3 goes away. I have a minus x and a plus x that goes away. So what I'm left with are these 3 terms that have an h in them. Okay? So I have a 4xh plus 2h squared minus h, and that is all over h. Now you could right now just divide into each one of those, or we can factor the h out of the numerator. They're both going to give you the same answer, but just so you can see what's going on, I'm going to do h. And then if I take an h out of these 3 terms, what is left? I'm left with 4x plus 2h minus 1. And it's all over h. But now it's easy to see that this h cancels with the h in the denominator. And the final answer is 4x plus 2h minus 1. That's the difference quotient. Okay, again, just get in touch. I'm happy to help you. Right? Bye-bye.